Hey, 20-1s. In this lesson, we're going to learn how to do something called completing the square. Now, I'm going to make two videos for this. The first one I've called visualization, so you can see what the heck it is we're doing. And the second one will give us a bit more of an algebraic approach to this. Okay, what is completing the square? Well, completing the square is the process which we're going to take to go from standard form, which we remember was written like this, to vertex form, which we wrote like this. So we're going to convert these forms. We already know how to go vertex to standard form. All we did was we multiplied everything out. We distributed, right, and collected like terms. Well, what we're going to do is we're going to go the other way today. We're going to go from standard to vertex, which will be a little bit more complicated. And this is called completing the square. So we'll complete the square. Well, the key words here are square. We're going to make a square and we're going to complete the square. So it's that complete part that I want to visually show you what we're doing. First, let's look at x squared plus 4x plus 4. Let's factor that. Well, that would be x plus 2, x plus 2. And we know we can write that in a slightly better way as x plus 2 squared. But what does that visually look like, friends? This is what's known as a perfect square trinomial. Square. Hey, there's that word again, square. So I'm going to draw a square. And our square is this. Has an area of x squared plus 4x plus 4. That's the area. These here are the length and the width. This is x plus 2 and x plus 2. And the area is what we get on the inside. X times x is x squared. X times 2 is 2x. X times 2 is 2x. And 2 times 2 is 4. So a couple of things I just want to point out here. Do you notice? So there's our x squared right there. There's our 4 right there. But the 4x is split up into two parts that are the exact same, 2x and 2x. So really, again, it's split up into two parts. That's the same as saying divide by 2, isn't it? So this is a perfect square trinomial. Perfect square. I always wonder why we call it a perfect square. Isn't just a square good enough? It's a square trinomial, but we always call it a perfect square. Mysteries of the universe. Okay, so what we just did here, friends, was we just completed the square. That's what that was there. This is in vertex form. If you want to think of this now, I'm going to convert this into a x plus p squared plus q. Look at that. We're now in vertex form. And now we can say this guy's been moved 2 units to the left and 0 up or down. So we know where the vertex is. It's at -2, 0. So it's really easy to complete the square when it's a perfect square trinomial and we're in vertex form. But what do we do when we're not a perfect square trinomial? That's where it's going to get a little bit trickier. So let's look at something that's not x squared plus 4x plus 3 this time. So what would this look like visually, friends? Well, it's going to be a square, a perfect square, I guess, but it's a square. And what do we know about our side lengths here? Well, I know these both have to be an x because we need that x squared there. And what do I know about these other two? Well, I know this one has to be 2x and this one has to be 2x because we have to split this perfectly in half. So our side lengths are x plus 2, x plus 2. Now, knowing what our length and our width are, or our side lengths, we can now say, okay, I know for certain then this one here has to be 2 times 2, which is 4. But I don't have a 4. I've got a 3. So how do we take care of the problem that I don't have a 4, I have a 3? Well, here's what we're going to do. I'm going to change how this looks. not what it's equal to. Let's put some makeup on it. I'm going to say this. I'm going to add in a 4. That's what I really want. That's all of that right there. That's what I want this to say. But I can't just add in a 4, can I? Like, I can't go to the bank and just say, give me $4 more in my bank account. They'd throw me out. So what we need to do is we need to balance this expression. If I added in a 4, then guess what I'm going to do? I'm going to take away 4 to balance it. And so now what do we have? We've got a perfect square in here. X squared plus 4x plus 4 is x plus 2 squared, and plus 3 minus 4 is minus 1. We're now in vertex form. We've completed the square. So again, what did we do? I looked at the x squared and the 4x, and I used that to figure out my first 3 quadrants of my square. And then I knew the last missing quadrant had to be 2 times 2 for 4. And to get that 4 in there, what I did was I added in 4, but I can't just add in 4 because now it's not worth the same amount. So to balance it, I subtracted that 4. Let's try this one more time. X squared plus 6x plus 10. Alrighty, here we go. So that's our area. So if we want x squared, I know this has to be an x and an x for x squared. The 6x, I'm going to split into these other 2 squares. So this is now 3x and 3x. 6x divided by 2 is 3x. Okay, so this then has to be plus 3 and plus 3. So what's this missing square over here? Well, 3 times 3 is 9. But I don't have a 9 in the given expression. I've got a 10. So to rectify that, I'm going to switch pen colors here. Let's go to bright orange. I'm going to add in a 9 here to get this 9. But to balance it, then I have to subtract 9 so that I haven't changed the value. I've just changed how it looks. So what do we have? Now we've got our perfect square, x plus 3 squared plus 1. And now we're in vertex form. So this is how we visually complete the square. It's not that bad until our numbers start to get more complicated. So as soon as I give us something in standard form that looks like this, with negatives and bigger numbers in them, it gets more complicated. And so that's where we've got the algebraic approach, which I'm going to show you in the next lesson. But the visual, again, completing the square literally means we're completing a square. We're finding the missing piece of a square. Okay, I'll see you in the next lesson where I show you how to do this cool thing algebraically.